Okay, guys, we're going to talk a little bit more about trig identities and simplifying. Today, the main focus is on making common denominators with fractions and understanding how you can use that to help you solve problems. So if we start with problem A, we see that we have just numbers in this case, 2/3 plus 1/4. And to make these common, the simplest idea is to take this 4 and multiply it to the opposite side, top and bottom, and the 3 and do the same thing on the right-hand side. So now we have something like this. 8 over 12 plus 3 over 12. And now notice that both of my denominators are the same. And so when I add these together, I get 11 over 12. Okay. And so we're going to use similar concepts to help us with working out some trig problems, okay? So I'm actually going to skip over B. We're going to take a look at equation problem C. So here's C. We see we have 1 minus cosine theta plus 1 over 1 plus cosine theta, okay? So again, let's start by getting common denominators. So I'm going to take this left-hand side, 1 minus cosine theta, and multiply it over here. And on the right hand side, I will take this 1 plus cosine, multiply it over here. Okay, so the top of these is hopefully pretty straightforward. We just get 1 plus cosine theta plus 1 minus cosine theta. Okay, now what about the bottom of this fraction? What's happening here? Okay, so these are going to actually get distributed to one another. Okay, so let's see what happens when you distribute this. So when we multiply 1 plus cosine times 1 minus cosine, we get something like this. 1 times 1 is 1. 1 times minus cosine theta, plus cosine theta, and then minus cosine squared theta. Okay, so those of you who are pretty observant will realize that these two middle terms right here cancel each other out. Okay, and this is a very common pattern, so keep that in mind. It pops up a lot. So here, now I've got my denominator as being 1 minus cosine squared. Okay, and let's see what's happening at the top here. So I see this plus cosine and minus cosine. When I add these together, they are actually going to cancel each other out. So on top of my fraction, I really just have a 2, which is this one plus this one. And then 1 minus cosine squared at the bottom. Hopefully by this point you are recognizing that 1 minus cosine squared is one of the Pythag identities. So this is right now equal to 2 over sine squared theta. And I hate leaving things at the bottom of a fraction like that. So you can think of this as 2 cosecant squared theta. Okay, and that's just using the reciprocal identity we've seen before. Okay, so again, these denominators look super complicated, but once you make them common and you can combine the pieces, it becomes a lot better to work with. Okay, let's take a look at problem D. Okay, so very similar idea. I have this fraction and I want to combine this tangent theta with it. So we have tangent theta minus secant squared over tangent theta. So here's what I'm going to do. I'm actually going to say this is tangent theta over 1. And how about we multiply this side by tangent on top and bottom? Okay, so this now leaves me with this kind of situation. Tangent squared theta over tangent theta minus secant squared theta over tangent theta. So with this, let's combine these two together. Tangent squared theta minus secant squared theta over tangent theta. So let's do some substitution. Maybe we can get something useful out of this. I know that tangent squared can be replaced with secant squared theta minus 1. So now this top part, secant squared theta minus 1 minus secant squared theta. Okay, what can I cancel out from here now? That's right, these two secant squareds can cancel each other out. And I'm left right now in this situation. I have negative 1 on top, and I have something like this. Negative 1 over tangent theta. Well, what is that? What is 1 over tangent? That's just cotangent theta. But since it's negative, let's just keep our negative sign. And here's a simplified answer for us. So as you can see, getting common denominators was an important part of this, okay? If you ever see fractions and multiple pieces that you need to put together, when adding and subtracting, you're going to need to find common denominators. Okay, and the last example for our video here, okay? Now, this one's a little bit tricky. There are some ways we can streamline what we're doing, okay? So you might think like, hey, let's just make common denominators and add these two pieces together. But here's a little bit of a idea. Since all of my functions are tangent and cotangent, okay, I'm going to change out this cotangent at the bottom. So this will be tangent theta over 1 over tangent theta. That looks kind of familiar, right? We can now flip this. So tangent theta times tangent theta over 1, which is tangent squared theta. Okay, and don't forget about this plus 1 we've had here. Okay, that guy's coming along for the ride too. Okay, but wait, does this look familiar? Tangent squared plus 1? That's right, it's one of our identities in your formula chart. That is equal to secant squared theta. Okay, so in this case, again, showing you that there are no absolute rules here. Okay, I could have approached it by making common denominators, but in fact, it's easier if I just simplify this fraction first. Okay, so occasionally, if you see an opportunity to simplify something, go ahead and simplify it first and then try to use identities on that. Okay. All right, so these were just some quick examples to give you some ideas on how you can solve some of the problems. Make sure that you work on your review and study for your test.